Okay, guys. So you get signed in, and we're not going to need the stuff on the Chromebooks right away. You may want to take down a few notes here just as we go along. So we're going to introduce the concept of graphing today. We will need the Chromebooks because we're going to show you how you build a linear graph using Google Sheets, okay? Because that'll be important for the lab that we're going to be doing on Wednesday of this week. Okay, we'll be using the Chromebooks for that. We'll build a graph just like you're going to build in the lab on Wednesday, so you'll have some experience with how that works. Okay. So big thing with graphing, guys, is it is one of the most important tools, no matter what science you're dealing with. Biology, chemistry, physics, okay, they're all going to need to use graphs. The benefit of a graph, or the purpose of a graph, is to give a quick visual reference of the relationship between an experiment's manipulated variable and its responding variable. Okay, that's what's always shown on a graph. Okay, and you might want to make a little note of this somewhere. The manipulated variable is always on the x-axis, and the responding variable is always on the y-axis. Okay, that way you can see what effect the manipulated variable has on the responding variable. If it goes up, if it goes down, okay, whatever happens. So this graph here is showing us the effect that temperature has on the rate of photosynthesis that a plant would carry out. Okay, can we pretty quickly see, just by looking at that graph, the relationship between temperature and photosynthesis? Okay? Like we can see that it's pretty low at low temperatures, okay? But it goes up a lot, actually fairly quickly, and then it just drops right off. Okay? It drops right off at about 30 degrees Celsius to the point where at 40 degrees Celsius, okay, or just about 37, almost body temperature, okay, it plummets to zero. Okay? So we can tell that, right? We don't have to read a big, long research paper about how they ran this experiment and all that other stuff, but we can get a quick reference just by looking at it. Okay? Now we have a general idea of the effect of temperature on photosynthesis. Now, if we want more detail, then we read said long, verbose research paper. Okay? Everyone with me there? So that's what the purpose of a graph is to give you a quick visual reference as to what happened in an experiment between the responding or manipulated and responding variables. Okay, what if I had an experiment where my graph went like this? Okay, what kind of a relationship is that? So on the x-axis, so let's say it's the same thing. Let's say it's temperature and rate of photosynthesis. Okay. This graph says that temperature has, what's that?
No effect.
No effect, right? The rate of photosynthesis did not change as temperature went up. Okay, if I ever get a graph with a horizontal line on it, whatever I did made no difference at all. Okay, the graph goes up, then obviously there's a positive relationship. As the manipulated variable increased, so did the responding variable. Okay, if the graph was to instead look like this, okay, then as the manipulated variable increased, the responding variable decreased. Okay, and I can see that as a quick reference. Okay, now I can get more detail off a graph if I want to, okay, as long as the graph is built properly. Okay, does this look like a pretty good graph? I mean, it's got a title, so I know what it's about, right? It's temperature versus photosynthesis. On the x-axis, they've got it labeled. That's where temperature is. That tells me that in that experiment, temperature was the manipulated variable. Okay, they tell me that the units are in degrees Celsius. It'd be a lot different if that was in Kelvin or Fahrenheit. Okay, so it's important to have the units there. And then on the y-axis, they have rate of photosynthesis. Is there anything missing from the y-axis? Because if I was giving this graph a mark out of 5, I would give it 4. Units. I have no idea what the units are for rate of photosynthesis. Okay, I would assume it's like milliliters of oxygen produced, or maybe milliliters of carbon dioxide consumed. I don't know. I don't know how exactly you measure photosynthesis, or micromoles of glucose. I don't know. It doesn't say that. It's hard for me to know that. Sure, I can see the relationship. That's important. But in terms of getting something like useful in terms of calculations from this, I can't do that without those units. I don't know what they are. Right? So on a graph, if you build a good, proper graph, you need a title. Okay? In fact, let's have you just draw a proper graph on here right now. Okay, just in your notes, just a rough one. Okay? Okay, so let's just say, draw this graph real quick. Okay, just a rough version of it, and then we'll fix the one thing that's missing, and we'll just kind of label what parts need to be on a graph. Okay, I'll give you just a minute here to get that. Okay, so this is our x-axis, okay, which is where the manipulated variable goes. Okay, and then this is the y-axis. That's where the responding variable goes. Okay, and then obviously we need labels and units. And obviously that's what's missing here. And then, I don't know, we can say milliliters of O2 or something like that for okay, so there's two reasons I would give this a 4 out of 5. Okay, first, it's missing the label on the y-axis, and secondly, did it make good use of the space? No, I could have got a better looking graph by not having the y-axis go all the way to 400. I mean, the highest thing on there looks like it's just over 200. Okay, so why waste all that space? Now, when we're building graphs with Google Sheets, you won't have that issue. It'll automatically fill, okay, unless something goes really wrong, and then you can usually fix it. Okay, but you should have no problem with picking the right scale, because Google's going to pick it for you when you build your graph. Okay, but if you see something weird, okay, where there's a bunch of empty space, usually just means you need to delete some stuff, and it'll come back, because we don't want to have a graph that, you know, we've compressed the important part, the data, because we've got a bunch of blank space. Right? It doesn't make good use of it. It doesn't make it look good and easy to read. Okay, this I would say that should have maybe gone to 300 or maybe even 250 as the maximum value, and that would have spread it out a little bit more. Okay, made it a little bit easier to read. All right, so proper graph has to have all of those things. Now, when you use Google Sheets to graph, it'll usually put most of those on there, but you have to tell it what to put there. Okay, if you just write rate of photosynthesis and you don't put in units, it's not going to put in units. It doesn't know what they are. Okay, so you have to make sure that you're entering all of that stuff. Okay, everybody with me there? Okay, now what I need you to do is in Google Classroom. Okay, I posted this morning just the graphing lesson here. So it says assignment. It's not coming in for marks. I just have to make it that way so everybody gets their own copy. Okay, so if you go into that, okay, there should be a Google Sheet there for you. All right, just open that up. think we'll start with the book thickness one. That's the one I have up first, right? Yes, okay. All right, so when you open this up, you'll see that there's a few different tabs down here at the bottom. Okay, I want you to just go to book thickness. Okay. Now, I want you to follow along with me up here on the board. I'm going to show you how to build this line graph, okay, in Google Sheets. So, what this is a graph of is the number of pages in a book, or sheets in a book, versus the thickness of that book, right? If I make more pages, will the book get thicker? Okay, so that means then that I'm going to want the number of sheets to be the x-axis and the thickness of the book to be the y. It's the responding variable, right? The more pages I make, the thicker the book gets. Everyone okay with that idea? Okay. Whatever you want to be your x-axis will always need to be in column A. Okay? Google will automatically assume you're putting the manipulated variable in column A, and it'll make everything else respond. Okay? So here's what we want to do. Okay? I want you to click and then drag to highlight all of the data. So put your pointer in 1A here, and then just click and drag until all of the data is highlighted. Okay, so it draws a box around. Okay, then you're going to go up to Insert. And you get this drop-down menu. You want to click Chart. And it's about a third of the way down. Okay, so most of the time, Google will do a decent job of picking the type of graph you want. Okay, and it should have done this. This is a scatter plot, okay, which is what we were looking for. Everybody with me so far? Or am I going too fast? Anybody have trouble? Okay. So now I've got my graph mostly built. Okay, it's got thickness in millimeters because I put that up here. Okay, and it's got number of sheets down here. Now, do I need units for number of sheets? No, it's a number. The axis already says number of sheets. Okay, so I wouldn't need another like set of units on that. Okay, so now I've got that built. I've got a title. Okay, as long as you like the title that it's made. Okay, you could change it to book thickness graph or something like that if you wanted to. Okay, but for right now, we'll just worry about this. Okay, right now it's got the points plotted, but what I want to see is their relationship. For that, I need a trend line, or what we in science will sometimes call a line of best fit. Okay, basically a line that follows the trend of the points. Okay, so right now we've got the graph that we want. Okay, it is a scatter chart. If it ever picks the wrong one, you just click up here where it says chart type. Okay, and you can pick a whole bunch of different graphs. This is what we want, so we're just going to stick with that. Okay, and we're going to go to Customize. So if everyone can click on the Customize tab there. Okay, this is where you can edit all the parts of your graph. All right, so if I wanted to go to Chart, Axis, and Titles, okay, there is where I could change the title. I would just click in here and type something else. Okay, if I wanted to change the y-axis, I would go to the vertical axis where it says thickness in millimeters, and I could change that. That's where you would make those kinds of adjustments. Okay, those are fine, so we're not going to do anything there. We want to click on Series. Okay, Series is where we'll do the bulk of our work when we build the graph. Okay, so we click on Series, and here's where you can change what your dots or points look like. You can make them basically anything you want, but for right now they're blue circles. I think 7 pixels is kind of big. I usually go to 2, but it's totally up to you. Okay, and then you can make them circles or triangles or stars or whatever suits your fancy there. Okay, doesn't really matter. You can pick. I'm just going to leave it as a circle. Okay, and what we want to do is scroll down a little further here to these 3 check boxes. Okay, one says error bars, one says data labels, one says trend line. All right, that is the one we want to click because it'll draw for us a line of best fit, which I gotta tell you, is super handy, because we used to have to do these graphs by hand, and everybody's trend line was a little bit different, because you had to put a ruler on there and kind of angle it the way you thought was best to follow the points. Google Sheets has got some kind of algorithm that it uses to decide where that should go, and it's usually pretty good. Okay, so once I click on trend line, then I get my line of best fit. Okay. All right, this one just happens to go through all the points. They don't always. Okay, very rarely do you get a perfect relationship like that where the line will actually go through all the points. And we're not connecting the dots, by the way. No pretty picture is going to get made. Okay, if we do that, it's just going to be a squiggly line. So our line of best fit is always a straight line that, as best it can, follows the points. Okay, as soon as we clicked on trend line, we're going to get another couple of options here. Okay, down below where it says label. We want to get the label for that line. Okay, so right now it says none. Okay, we just want to click on that, and the bottom one is the one we want here, use equation. Okay, so just click on use equation, and when you do that, it'll put it up at the top. Okay, so at this point, your graph is complete. Okay, it has everything on it that you need. I should take the picture. Okay, so now that we've got that, now we're going to work on what is this thing showing me? Okay, what is the information on this graph telling me? So that little equation there at the top is y equals m times x plus b. I used it last week when I was teaching you how to manipulate equations. Okay? It is the equation for a linear function or a line on a graph. Okay? So what this one is saying is this. All right? It is saying that y equals m times x plus b. Now, this is something you're going to want to add to your notes. Okay? Put this equation in there, and I'm going to tell you what each of the parts means. Okay, so the y value, okay, or y in this equation, is the vertical or y value of any point on the line. Okay, not necessarily a point you plotted, but any point on the line. Okay, so if we were picking just like, I'm going to pick this spot right here. Okay, it's not a point that we plotted, okay, but the y value for that point would be 15. Okay, so y is any value of y anywhere on the line. Okay. Okay, so y is the y value of a point on the line. X similar. Okay, so x has to be, of course, for the same point. Okay, so when we're dealing with y and x in this equation, we are talking about one point on the graph. This is the y value of that point. This is the x value of that point. Basically, we're telling people the coordinates of that point. Okay, m is the slope of the line. slope is the rate that y changes over x. Okay, that'll make more sense in a minute. Okay, and b is the y-intercept. Okay, that is the value of y when x is 0. Okay, so the purpose of this equation is that it allows us to calculate values on the graph that we may not have plotted. Okay, so that little black dot that I put on there is not one of the values in the data that you had. Okay, it's one I just put on there. I was able to figure out, because it was right on a line, what its y value is, but I don't know what its x value is exactly. I know approximately, but not exactly. Okay? I could use that equation to calculate what x is based on how steep the line is, m, okay, and what y is, and also what b is. Okay? All of those things will allow me to calculate that. It's also useful if I want to extrapolate. Okay? Extrapolate means I want to calculate the thickness of a book that is beyond 100 pages. This graph only goes up to 100 pages, but if that line holds true, I could, as we're going to do in question number 2 there, calculate how thick a book with 805 pages would be, okay, based on the relationship that's on this graph. Okay, so y equals mx plus b allows us to calculate values we didn't plot and values beyond what was plotted, so beyond the graph. Okay? All right, m, the slope. Slope's probably the most important part of that equation. It tells you numerically the relationship between your manipulated variable and your responding variable. Okay? Here I wrote it's the slope of the line, it's the rate y changes over x. Okay? On this graph, if I'm looking at m, the slope of the line, it's telling me how many millimeters per sheet. Right? Every time I put in one more sheet, it's going to get, the book is going to get 0.15 millimeters thicker. That's what the slope is telling me. It's basically telling me the thickness of one page. Okay, that's what the slope on this graph is telling me. And it's telling me that every time I add a page to the book is going to get 0.15 millimeters thicker. Okay, everybody okay with that idea? So if I know how much thicker the book gets with every page, I can easily calculate how thick a book with 805 pages would be. Okay. All right. So let's do a couple of example ones here. Okay, so just kind of write down the examples that we're doing here. Just don't bother with copying the graph down, just in your book, write what we're about to do here. Okay, so we're going to do question number 1, calculating the number of sheets in a book that is 80 millimeters thick. Oh, yeah, right here. So this question wants me to calculate the number of sheets. Which axis is number of sheets on? It's on the x-axis. So it's asking me calculate what x is when y is 80 millimeters. Okay, because it wants to know how many pages in an 80 millimeter thick book. That's beyond the graph, but I can use the graph to calculate that. So it told me, here's a y value. The equation told me what m and b are, and it always does. Okay, your equation will always tell you what slope and y-intercept are, and then you can use it to calculate either y or x if you're given the other. So in this case, we're given y and being asked to calculate x. So we're told it's this thick. How many pages does it have? So basically, we're told in question number 1 that y is 80 millimeters. Okay, we know m because the equation gave it to us. Okay, and I also know b. How did I know b was 5 millimeters? Okay. B is the value of y when x is 0. Everything that's a y value is in millimeters, according to this graph. Okay, so when I get something that's in millimeters, I know I'm being given a y value. Okay, and b is always a y value. It's the first y value. Okay. So if b is the value of y when x is 0, a book with no pages has a thickness of 5 millimeters. What's that telling us? I would say that's the thickness of the cover. Right? A book with no pages still has a cover. Okay? So when there's no pages, here's how thick the book is. Well, that would imply that the cover must be 5 millimeters thick. Everyone okay with that? Okay. Those are the kinds of kind of assertions that we need to make when we're reading a graph sometimes. Okay? The conclusions we have to draw. All right, so we want to solve for x. Okay, well, if y equals m times x plus b, I got to do a little bit of algebra here, okay? Stuff we were learning last week. I want to isolate x. What should I move first? What's not attached to x? B. B's not attached to x. Okay, so I'm going to move b first. Right now, I'm adding b. I want to move it to the other side, so I subtract b. All right, so then I'm going to have y minus b equals m times x, because I subtracted b from that side, and then I subtracted b from this side. Okay, so now I've got y minus b equals m times x. How do I get m over to the other side?
Divide by m?
Yeah, divide by m, because right now I'm multiplying m by x. If I want to move something, I do the opposite. So, okay, I divide this side by m and this side by m. All right, now I'm solving for x. Now all I have to do is plug in the numbers that the question gave me. Okay, so y, it said, was 80 millimeters minus 5 millimeters divided by 0.15 millimeters per sheet. Okay. So when I do this, the millimeters will cancel, and I'll be left with sheets, which is what I was looking for. Okay, now here's the only trick with this. If you punch this into your calculator like this, okay, and you go 80 minus 5 divided by 15 all in a row, will you get the right answer? You will not, okay? Because your calculator is programmed to do order of operations if you just type in a big long equation. So it'll do the division first. We don't want the division first. We want the top divided by the bottom, okay? So we'll go 80 minus 5, close the brackets, and then divide by 0.15. Okay, so according to this graph, a book that's 80 millimeters thick has 500 pages. Okay? Or sheets, I guess, is the units they use, so that's what we should use. 500 sheets. Okay? So all graphs work just like this. So what you're doing on this graph is not specific to books and pages. Okay? Any graph that has an X and a Y, you can do this for. You're just not going to get millimeters and sheets. You could get meters and seconds, or you could get dollars per month, or whatever. Okay? It depends what's on the graph. The units are always going to be different, but the method is always going to be the same. Okay. Let's try number 2. Okay. Number 2 wants us to find out how thick a book with 805 pages would be. Okay, so thickness is on which axis? Y. It's on the y-axis. Okay, so we're being asked to calculate thickness. We don't know what y is. Okay, but we are told the book has 805 pages, or 805 sheets. Okay, so x, because that's what's on that axis, number of sheets, is 805 sheets. Okay, and it's still the same graph, so m and x are still the same numbers. M is still 0.15 millimeters per sheet, and b is still 5 millimeters. Okay, so I'm trying to find y. Okay, and I know that y equals m times x plus b. Do I have to do any algebra? I see Brady nodding his head no. Okay. I already have everything, right? It's already set up for this. All right, so all I have to do is plug my numbers into the equation. Okay, so 0.15 millimeters per sheet. Okay, times 805 sheets minus 5 millimeters. Okay, well, when I multiply millimeters per sheet by sheets, sheets are going to cancel. Okay, and I'm going to be left with millimeters, and I'm just going to be subtracting millimeters from millimeters. Okay, so if I punch all that in, 0.15 times 805, okay, minus 5. Okay, so that book will be 115.75 millimeters thick. Okay, everybody all right with what I did there?
Can you subtract the 5 in the equation?
Because I'm an idiot. Good idea. Yeah, that should be plus. I don't know why I subtracted. So it should be 120.75, yeah?
What's in the 125?
125. Okay, yeah, my bad. I don't know why I subtracted. Been that kind of day so far. Okay, Any other questions on that? So, on any graph, okay, that's linear, so it has a nice straight line like that, that equation will apply, right? The things that are in it will be different. It'll always be y is m times x plus b, but what y and x and b are will be different. They'll represent different things, okay? But a linear relationship, regardless of what it is, okay, is going to work the same way. Okay, all right, let's try the next one here. What's the next one I had? Okay, so let's go to the diameter versus circumference one. So that was the first one. I call it circles graph on here. So if everyone can just go to the circles graph tab. Okay, see if you can build the graph without, give you like 2 minutes to see if you can get that graph built, and then I'll walk through the steps again. Okay, highlight, insert chart, okay, that kind of thing. Give me a minute. Okay, so if I'm building this graph, put my pointer in A1, okay, and highlight, click and drag, okay, highlight everything, go to insert, and then chart. Okay, so I get this, and then everything is set up the way I want there. So now I go to customize. Okay, and then customize, looks like everything's already good. Circumference in meters, diameter in meters. Okay, I've got a title, circumference in meters versus diameter in meters. Okay, so that's good. What should the relationship be between diameter and circumference? Like if you have diameter and you want to calculate circumference, what do you have to do? Times by? Not 2, it's a special number. Sounds like a food. Pi, yeah, okay. So the relationship between diameter and circumference should be pi, 3.14. Agreed? Okay. So when I put my equation for my line on here, what should the slope of the line be? If the relationship between diameter and circumference is pi, the slope of the line should be 3.14. Yeah, should be pi. Okay. All right. So let's go to series. Okay. And in series, this is where we've got all that stuff about the points and the line and everything. Okay. Scroll down and go to trend line and check that box. Okay. And then on label, use equation. Okay, now it only shows it to 1 decimal place, but so far so good. Okay, 3.1 is pretty much 3.14. Okay, so now I've got my graph. Everybody good with that? Okay. Now, it's also telling me that my y-intercept is actually a number. That might be a mistake. What should the y-intercept be for a graph of diameter versus circumference? If I have a diameter of 0, what's my circumference? 0. That should be the first point, okay? I should actually have a graph that starts out at 0, 0, okay? Because I've rounded off some of these numbers, Google just runs its algorithm and says, here's where the line should go. It's close, but given the nature of my measurements, they're only accurate to the nearest 1/10 of a meter, okay? It's not gonna be all that accurate either. Graphs have limitations, okay? What a graph can show is limited to what you told it, right? And if I'm only saying, you know, to the nearest 1/10 of a meter, that's to the nearest 10 centimeters, it's not gonna be super exact, right? I should probably have gone a lot deeper on all of my measurements here. Everyone okay with that? But it's generally showing the right thing, agreed? All right, so let's go back to this. Okay, so using that equation, oh, I use different numbers. Was I on the right graph? It was, right? Oh, I just changed my numbers. Okay, so on that graph, okay, so we've got the graph here. I want you to see if you can calculate the circumference of a circle that has a diameter of 0.88 meters, okay, as well as the diameter of a circle whose circumference is 41.5, okay, using the equation for our line. Okay, so this one here. Okay, I'll give you a minute to do number one and then we'll walk through it together. All right, let's look at number one. Okay, so number one here, we're looking for the circumference. Which axis is circumference on? Okay, which axis is this? Y. Okay, so I'm looking for Y, and they told me it has a diameter, which is on the x-axis, of 0.88 meters. All right, so I'm given X, and I'm looking for Y, and of course I've got M and B. So for question number one, I don't have to do anything except plug my numbers in. Okay, so if I do that and I go 3.1 times 0.88 plus 0.149, okay, I should get the circumference of that circle. All right, so 3.1 times 0.88 plus 0.149. This time I'm actually plussing like I should. Okay. All right, so it would have a circumference of 2.877 meters. Okay, now try number two. In number two, you're looking for the diameter, which is on which axis? X. Okay, so now you're solving for X. They're telling you the circumference, so they're giving you Y. Okay, you're trying to solve for X. Give you a minute on that one. Okay, let's have a look at number two here. So on number two, we're being asked to solve for X, and we're given what Y is. So M times X plus B. Okay, so if I want to solve for X, what do I move first? B. B's not attached to X. All right, so I have to subtract B because currently I'm adding it. So Y minus B equals M times X. Okay, I want to get X by itself. Right now I'm multiplying by M. The opposite of multiply is divide. Divide both sides by M. Okay, now I'm solving for X. Now I can plug in my numbers. They told me Y was 41.5 meters. Okay, B is 0.149. And then I'm going to divide by M, which was 3.1. All right, on this one, again, you need to do that top part first, 41.5 minus 0.149. Now I can divide that by 3.1. Okay, so the diameter of that circle would be 13.3 meters. Okay, so the good news is no matter what kind of graph you have, the way y equals mx plus b works is always the same. What it calculates is going to be different. M could be different on every graph. Y is going to be different on every graph. X is going to be different on every graph. But how you calculate those values is always the same because it's always the same formula. Okay, okay. Need any more time on that one? Okay, let's do the rubber band one next. Okay, so just go to the rubber band tab right here. It's the one right next to the one we were on. Okay, I'll give you a minute to build the graph. See if you can do it without me this time. Okay, so building that graph, okay, click and drag till you highlight all of the information. Okay, and then insert chart. Okay, we get that. Looks like everything carried over. I've got the right units. I've got labels and title. Okay, so I can go to customize and go to series. Okay, and then in series, scroll down to trend line and check that box, and as soon as I check that, it gives me the other options I need, like the label, where I hit use equation. All right, so the length of this rubber band is represented by the relationship of 2 times x plus 6.5. Okay, now before we do anything else, let's talk about what that's gonna mean. Okay, so y equals 2 times x plus 6.5. So 6.5 is b. B is the y-intercept. It is what the value of y is when x is 0. And what's on the x-axis of this graph is stretching force. So the y-axis is length. What is the y-intercept? What is B telling me about the rubber band?
That the rubber band is 6.5
Meters.
meters.
Yeah, it's ridiculous. It's like a bungee cord or something. Yeah, it's 6.5 meters long, unstretched. Okay, that's why the y-intercept is 6.5 meters. This is the length of the rubber band before anybody starts to pull it. Okay, does that sort of make sense? These are the kind of things we want to be able to draw when we're looking at a graph. Okay, so when there's no force on the rubber band, it's 6.5 meters long. Perfect, okay. Now, what are the units going to be here for my slope? So m is 2, okay? The slope tells me how much y goes up as a function of x, and its value is 2. Okay, 2 meters per Newton. That's what N stands for. Okay, 2 meters per Newton. So for every 2 meters longer the rubber band is going to get, I will need to apply how much force? It's in meters per Newton. Okay, so if I want to go 2 more meters, I'm going to have to apply 1 Newton of force. The slope is 2 meters per Newton. Okay, slope is always going to be units of y over x. Okay, it's telling you how much y changes as a function of x. So y changes by 2 meters every time I put 1 more Newton worth of force into that rubber band. Okay? Everyone all right with that? In the last graph, the circumference got 3.14 meters longer every time I added another meter to the diameter. Okay? Slope is always telling you y is going to change this much for every increment of x. Okay? All right, let's look at the questions for that one. Okay, I'm going to give you a few minutes. See if you can try these ones on your own. Okay, how long will the rubber band be if you use 15 newtons of force to stretch it, according to the equation we have? Okay, how much force would be needed to stretch the band to 18.7 meters? And we already did number 3. What was the answer to number 3? 6.5 meters, right? Okay, so try 1 and 2. They're just going to involve you manipulating y equals mx plus b. All right, for number 1, we're looking for how long the rubber band will be, which axis is length on? The y-axis. Okay, so we're solving for y, okay, when x is 15 newtons, because stretching force in newtons is on the x-axis. So we're going to have 2 times 15 newtons plus 6.5. So 36.5, I'm not even going to punch that in, 36.5 meters, okay, because this will be in centimeters per Newton, okay, and this will be in newtons, so the newtons cancel, and then I've got centimeters as my units. Okay, how many people have done number 2? All right, let's have a look at that one. Okay, so on number 2, it wants to know how much force. Force is on the x-axis. So I'm going to have to manipulate this formula now for x. Okay, so first I subtract b. So I'll have y minus b equals m times x, and then I'll just divide both sides by m, and now I can plug in my numbers. Okay, so they gave me y, 18.7, minus b, which was 6.5. Okay, and then I'm going to divide that by 2. Okay, so 18.7 minus 6.5. Okay, whoa, that's not right. 18.7 minus 6.5. Now divide that by 2, 6.1. Okay, so I'll need 6.1 newtons worth of force for that temperature. Yeah. Okay, questions on how that worked? Okay, is the using the equation the same no matter which graph I give you? It is. Okay, that's the thing to know. Be able to manipulate this formula, and you can deal with any linear graph I throw at you. Okay, because it'll all work the same. All right, now I want you to go to the multiple run graph. Okay, so just click on that. And you'll see that now it looks different. I have 4 columns worth of data. So this is basically a race between some battery-powered toy carts. And what it's showing us is, or what the data is telling us, is the position of those carts, where they are, as a function of time. So basically, how far did they go every second? Okay, so we're going to build this graph exactly the same as the last graphs we built. Okay, put your cursor or pointer in A1 here and click and drag until you highlight all of the data. Okay, Google knows you want the first column to be the x-axis. It's going to put everything else on the y-axis. However, it is going to get confused when it comes to labeling. Okay? It's not going to know exactly what you want, okay, in all the different places. All right, so I've got it highlighted. Okay, I go to Insert and I go to Chart. Okay, it guessed wrong. Do I want a bar graph? A bar graph is really not appropriate for what I'm dealing with here. Okay, so I don't want that. So here's the first time you're going to have to do this. Here where it says chart type, it says column chart. I don't want that. I want a scatter plot, okay, which is what we had on all the others. So just click on the drop down, and you just have to scroll down a little ways. Okay, right underneath pi is scatter. Okay, so just click on scatter, and now it looks the way we want it. Okay, each car has its own set of colored dots, exactly what we want. Okay, so now we're good, except what's missing from the y-axis? There's no label and no units. All right, so I'm going to have to put that in. So I'm going to go to Customize. I have the right kind of chart now, and I'm going to go here, Chart, Axis, and Titles. Okay, and it automatically picked the one that was missing, at least for me. It might not do that for you. Okay, you want this to say Vertical Axis Title. Okay, so click this drop down if it doesn't, and select Vertical Axis Title. Okay, according to our data, the y-axis is showing position in meters. So that's what I would type in. Position, and then in brackets, meters. And it'll update it as you go. Okay, so it's already put it on there. Okay, also look at my title. That title kind of sucks. Okay, it's not very good at all. So I'm also going to go to Chart Title, and I'm going to clean this up. And I'm just going to say position versus time. Okay, so when you do a graph that has more than just an X and a Y, it's got several runs, you'll have to do that. So on Wednesday, you'll have to do what we just did. Change the title and add a label. All right, from here, same thing we did before. So I'm gonna close up the chart axis and titles, and I'm gonna go to series. Okay, and if I scroll down, check the box for trend line, just like we did before, okay, and put in the equation. Okay, now you got a graph for that. So we'll talk about this graph tomorrow because we are out of time here now. Okay, because we got the short classes today. Pretty sure it's 9:50. We're supposed to be done, right? I think it's 9:50. Okay, so can everyone please log out, shut down, wait for it to go off, close it up, put it back in the correctly numbered slot. Light facing out, the circled one. Plug it in.